Okay, here we've got the notes for page 5 to go with our chapter 8 notes for an integrated 3. Now we're going to be talking about how you can actually divide polynomials. So first semester we did stuff like f of x over g of x. And I said, just stop there. Just write it down. Don't do anything with it. I'll show you how to divide later. Well, now is the time. So what we like to do, or one way to do this, is to use an area model to divide. So here's how we set it up, and I'll go through the example. It's already worked out here, but I think it might actually be easier to just kind of do it ourselves. So I am going to do a decent amount of color coding, just so you guys know. First thing that I would want to do is I'm going to take whatever I am dividing by. So the thing after the division symbol, which can also be written on the bottom of the fraction, and I'm going to put that down the outside left portion of a generic rectangle. And actually, when I build it, I kind of leave it open-ended because I don't really know how many boxes I'm going to need. Then I start placing items inside the boxes. So the very first thing, and it really is about the very first piece. So this x to the fourth, which is the where we would get the degree from the polynomial. So look for the biggest exponent. Doesn't have to be first, just look for the biggest one. In this case, it did come first. It is the only thing that automatically gets placed into the very first box. That's it. Everything else you now create and generate yourself. So what we would do from here is I would take a look at these two things put, whoa, that is not what I wanted. These two things put together. I know that this x is on the outside of the box and the x to the fourth is on the inside of the box. So going back to what we know, I know that x, so this guy on the outside, times something has to give me the thing on the inside, the x to the fourth. That's what you're going to be looking for next. So what is that something that goes here, so that when those two are multiplied together, you get the x to the fourth on the inside of the box? Well, we know that it's got to be x cubed. Once that x cubed is created, now we're going to continue the multiplication with this guy on the outside. So I'm going to take this -2 and I'm going to times it by the x cubed to figure out what goes inside the box next to that. That's where I get the -2x cubed from. Okay, now going back up to the original question, we're now at x cubed. So look at the term that's in x cubed. So we have a -6x cubed. In this diagonal, so in this diagonal box, we need those two things to total the -6x cubed. And by total, I mean we want them to add together to get -6x cubed. Okay, so we've got the -2x cubed from the multiplication. The only way that you're going to add -2 to something to get -6 is a -4. So we have a -4x cubed. Now you do the exact same thing you did just a minute ago. We have the x on the outside. It's going to be times by something to get the -4x cubed. Well, it's a -4x squared. Now you multiply that value times -2 to get the value that goes in the bottom again. And that is where our positive 8x squared comes from. Now you go back up to the original problem. You look for the x squared term, since that's where we're at. There's no x squared term. So I want a 0x squared because there is no x squared at all. All right, well, the only way to get that is if I have a -8x squared. Remember, I'm adding these together. So these two get added together, excuse me, to get my 0x squared. And then we continue the process with the multiplication on the outside. So I'm going to get rid of my arrows here, so it's getting a little messy on the side. And we do the exact same process. So I'm going to take 8 times something, well, the something is negative 8x, to get the negative 8x squared inside the box. Now I'm going to take the negative 2, and I'm going to times it by the negative 8x to figure out the 16x inside the box. Now I start again. I go back up and I look for the x term. Well, the x term, let's do a different color here that was already used. So my 16x. Okay, my x term is an 18x. Well, the only way I can get an 18x with a 16x already created is by getting a 2x involved. Now we go through and do the exact same process again. So x times 2 has to give me the 2x that I want. Now multiply times the outside again, and that's where my negative 4 comes from. Okay, so now we're basically in the home stretch. We're not quite there yet. So there's my negative 4 when I multiply. All right, let's get rid of this. Now, if I go up to my constants, I've got a negative 1. All right, so these two together need to give me negative 1. So the only way to do that is with a 3. Well, at this point, we're now at the constants. So once you've reached the constant, this number, whatever gets put here, is identified as your remainder. So your answer to this division problem is the stuff that is across the top of the boxes. So if we take a look, here is our x cubed minus 4x squared minus 8x plus 2. Okay, so as a reminder, back from 4th or 5th grade, I think, when you guys learned to do long division, remember, we write remainders so that it is the number, so whatever the remainder is, over what you were dividing by in the first place, which is the stuff out in front of the boxes. And it is a positive, so make sure you put a plus sign there. And that's what we have at the very end of this thing. Okay, let's actually go through and do a division problem ourselves. So, first and foremost, I am going to take the x plus 3, and I'm going to place it down the side. Going to start setting up a generic rectangle. Now, I don't like to close it off because I don't know how long I need it to be. Okay, if I take a look now inside and I find the term with the highest exponent on the first guy, so that's going to be my x squared. That goes into the very first box. From here, I have to do all of the work to get everything else. So I would ask myself, x times what gives me x squared? Well, the thing that does it is x. Now that it's up there, I can now figure out what goes down in the bottom box. So when I multiply, I'm going to multiply my x and my 3 to figure out what goes there. Well, my x times 3 is 3x. Okay, let's go ahead and close that box. Now I'm at my x's, so these two boxes together have to give me this negative 4x. Okay, well the only way to get a negative 4x when I put those two together by adding is putting a negative 7x here. So you want to do a quick check and make sure that 3x and negative 7x give us the plus 4x that we need. Okay, now we've got that. Now we got to figure out the multiplication again. So, figure out what goes there. So x on the far left-hand side times something has to give me negative 7x. Well, that is negative 7. Once that's up there, now I need to figure out what goes in the very bottom box. So I need to fill in this box. So I'm going to do negative 7 times positive 3. That's going to give me negative 21. Okay, close that box. Now I'm on to the constants. I go back to my question and my constant is negative 21. I have a negative 21 already. Remember that these two boxes added together have to give me that constant. Well, I don't need anything to get the negative 21. Okay, close the boxes. I reached the constant, so this is my remainder. I don't need the rest of the box here. So now my answer is what's written across the top. So the answer to this division problem is going to be x minus 7 from across the top. Since the remainder is 0, we don't have to write it. So the answer is x minus 7. Now, it takes a little bit of practice, but it really is about the diagonals themselves inside the boxes. Okay, I do have a couple more problems to go through with you guys, and then I've got some practice problems for you as well. Okay, let's go ahead and move on to example 2 and example 3. Okay, example 2, I notice that the thing that's going into the boxes, like pieces at a time, isn't in order. So I like to rewrite it. So I want my n cubed to come first, so my highest exponent. Then I'm going to have my n squared come second, my n come third, and my constant come last. Now that it's in order, I think it might be a little bit easier to figure out, like, what do I need extra? Okay, so take the thing that you're dividing by and put that off to the side. Open up your box. And then you can close it if you want to. I like to leave it open until I'm done. All right, first term. So the first term that we're dealing with here is the n cubed. So the n cubed is going to go right there. Keep in mind, it's the only thing that automatically goes directly into the box. It's the only thing. Everything else you got to kind of work for. All right, so now we have to multiply. So n cubed times something has, n times something has to give me n cubed. Okay, so that's going to have to be an n squared. Now I'm going to multiply. So I'm going to fill in the bottom box. If I fill in the bottom box here, then we're going to multiply these two. So that's going to give me a negative 6n squared. All right, now I know that these two boxes together have to give me whatever my n squared term is, so positive n squared. All right, so adding them together, the only way I can get a positive n squared is if I have a 7n squared here. Okay, now I have to figure out what goes on top. So n on the far left-hand side times something has to give me 7n squared. Okay, well that's going to be a positive 7n. All right, once I have figured that out, now I can fill in the bottom box. I'm going to fill this guy in. Okay, that's going to give me, I'm going to multiply, since the stuff on the outside of the boxes get multiplied to create the stuff on the inside. If I multiply those two, I think I get negative 42n. All right, now I have to figure out my n. Whoa, I have to figure out my n's. Sorry, I forgot to grab my highlighter there. And I want to get negative 47n. Okay, I've got negative 42n right now, so I think I need a negative 5n for this. Close the box. Figure out what goes on top. Okay, so n times something has to give me negative 5n. My that's just going to be a -5. Now that that's up there, now I can multiply to figure out what goes in the very bottom box. So the very bottom box here now is what I'm filling in. So I'm going to multiply the -6 and the -5. That's going to give me +30. All right, go back up to the question. Find the constant. It's a +30. All right, I don't need anything else, which is kind of nice. So my remainder is going to be 0. I can close off the boxes, and you can either erase it or just leave it there. Just know that you're done at that point. All right, so now I look across the top of the boxes, and this is going to be my answer to the question. So equals, and I ended up with n² plus 7n minus 5, no remainder. Remainder is 0, so I don't have to write anything there. Okay, let's take a look at this next one. We go through and do the exact same process. Really does end up becoming like muscle memory. So the more you practice, the more you're like, oh yeah, this puzzle goes here. It really is kind of like a puzzle. So I'm going to reorganize this because it doesn't look like it's in order. So biggest exponent comes first. So 4x to the 4th. Next exponent is a 6x cubed. Next one is a -6x squared. Then my x. Then my constant. Okay. I prefer to have it in order just so I don't miss anything. All right, so off to the side, I've got a 2x plus 1. Create the generic rectangle. Again, I don't know how big I need it to be, so I kind of draw it out fairly long, and then I just start filling stuff in. All right, let's start at the top. So I have a 4x to the 4th. Remember, that is the only thing that automatically gets placed inside the box. So there's my 4x to the 4th. Okay, now your job is to figure out what goes there to be able to get the 4x to the 4th when you multiply. All right, well, 2 goes into 4 2 times, so it's got to be a 2. And then you have an x and you need an x to the 4th, so that's an x cubed. Okay, let's close off this box. Now we have to figure out what goes in the very bottom. So we've got to fill in this guy here. All right, now we're just going to multiply because we've got a 1 on the outside and a 2x cubed. So this gives me a 2x cubed. All right, now remember that the diagonals have to add to give you, so these guys go together, have to add to give you whatever your x cubed term is. Okay, well, it's a 6x cubed. All right, I have a 2x cubed. I think I need a 4x cubed to get the 6x cubed I'm looking for. All right, now we're going to divide. I'm going to figure out what goes up here. So I know that 2 goes into 2. That's going to be a +2, and it looks like I need an x squared to get that to work. Okay, now we fill in the bottom box. Got to figure out what goes there. Multiply those two together, so we get 2x squared. All right, close it. Now we need to figure out what goes here. Remember, these guys go together. So they are x squared, so go back up and find the x squared term. All right, I need a -6x squared when I add 2 and something. All right, to get 2 and something to give me a -6, I think I need -8x squared. All right, close it. And we got to figure out what goes there. All right, so I'm dividing. So 2 goes into -8. That's going to be a -4. Looks like I need an x. Okay, now we need to fill in the bottom box. Hopefully you're kind of getting the hang of this puzzle thing. You're just kind of filling little pieces in as you go. All right, so when I multiply the -4x and the 1, I get a -4x. All right, now I am at the x term, so I need a -2x. So I'm going to figure out what goes there. Remember, those guys go together. I have a -4x. I want a -2x. And the only way this is going to work is if I have a +2x. You'll notice too that I'm kind of running out of room. So I'm just going to go ahead and extend the generic rectangle. Close this guy off. All right, now I've got my 2x. I need to figure out what goes on the top here. I think it's just a 1. So 2x goes into 2x one time. Got to fill in the very bottom here. Multiply. 1 times 1 gives me 1. Oh, I don't want to use the same color. I believe that's a 1. All right, now we'll go back up to the constant. All right, we don't have 1 here, so it looks like we are going to have a remainder. All right, so let's figure out what goes in that box. Remember that these guys get added together. And I think it's a -8 to be able to get that -7 that we want. Okay, and I do have a remainder this time. All right, so I'm going to write my answer from across the top. So I have a 2x cubed plus a 2x squared minus a 4x plus 1. Okay, now I've got my remainder. Well, my remainder is negative, so let's put a negative sign. The number is 8, and what we were dividing by on the far left-hand side was 2x plus 1. So there's my answer to example number 3. All right, I do have a couple practice problems for you guys to do, so if we were in class, I would have you put these on the back of one of the pages in your notes. You don't need the graph portion of it, you just need the blank spot. Okay, so here we go. We have a quotient problem that we want to find here. And I don't want to mislead you into thinking that that's a 12, because it's not. So let's cut off the edge of the Q for quotient there. All right, go ahead and pause. See if you guys can set up the problem, do the division problem, and then unpause and then see if you match. And I'm going to go ahead and just have it worked out for you when you take the pause off. So good luck. Okay, so I went through and I worked this out. I did do my color coding, so hopefully that should be a little bit easier to kind of follow along, and then I have my answer off to the side. Also, now would be another time to pause if you want to double check your work real quick or see if you can find your error in here. I am going to go ahead and move on to the next question. Okay, so here is the next question for you guys. Again, go ahead and pause. See if you can get the same answer that I do. Okay, so now we've got example number 5 all worked out. Again, it color-coded everything so that you guys can see which ones go together. And then this one didn't have a remainder, so I don't have to write that fraction at the end. There is practice for you guys also in the folder, so on the calendar. Go through and practice these problems. I believe that the answer keys are also supplied for you. Remember, if you have any questions, just reach out to me.